as we prepare to go into algebra so we can tackle more interesting problems, we need to expand our number system and arithmetic operations to signed numbers and understanding how to do arithmetic with these numbers. Signed numbers are an important step, and signed numbers just include negatives in addition and subtraction to the numbers we're already used to working with. They're not terribly hard to work with. We just need to keep in mind how signs interact with subtraction and addition so that we know, what kind of operation we're doing, also with multiplication and division. So this is the number line, and as we continue on to the right, we get more and more positive, which means we get greater and greater numbers, right? 1 million is greater than 1. Well, as we go more and more to the left, we get more and more negative. And these numbers are always less than every positive number. So, for instance, 1 here is always greater than all of these numbers because it's more to the right of it. And the more right the number is on the number line, then the more the bigger the number is, quote unquote, bigger the number is. Think of it like debt, right? If you have 0 debt, you have you're in a better position than if you have $5 of debt. That's the kind of idea you can use if the understanding of negatives is a little confusing. All right, so let's actually do some problems with these. Comparing negatives with positives is all about just saying which one is further right than the other one. So in this case, 19 over 5, right? If we draw a number line, 1, 2, 3, 4, 5 would be here, and then somewhere way down here we would see 19, which means 19 is greater than 5. It opens towards the bigger number. A positive number is always greater than a negative number, and the same thing with 0. 0 is always greater than a negative number. Negative numbers tend to be the quote-unquote smallest. It's a little bit weird to say that because, as you see here, right, the 5 is definitely bigger than 1, but once you add a negative sign, it flips. -1 is definitely is further to the right, right? -1 is here, it's further to the right of 5, therefore it's greater than 5. So you can think of it like the bigger the negative number, the smaller it is. I hope that makes sense. -7 and -7, well, those of course are equal to each other. And here we have -22 and -48. -22 is greater than -48. If you owe $22, that's better than owing $48. Okay. So what negative actually means is taking the opposite of something. So if we're trying to find the opposite of 9, what we're doing here is we're saying, what is the negative of that number? Well, the -9 is just -9. What this means is on a number line, just kind of as a reference point with 0, if 9 is right here, the opposite of 9 is flipped straight across the 0. So this distance is the exact same as this distance. This is a very important concept in mathematics because it talks about what are called inverses of each other, inverse numbers. They're actually it's a necessary thing to have in our mathematical system. And if we didn't have it, a lot of nice properties that we use in mathematics, a lot of the nice things that you're used to working with would break down. So it's important that we have this idea of an inverse number here for addition and subtraction. Okay, so taking the opposite of -34 means taking the negative of -34. And two negatives become a positive. Now 0 is the interesting number, right? As I showed you here with 9, this yellow distance is the same as this orange distance. But for 0, 0 is right there in the center. That's the point that we're referencing to. What that means is that 0, because 0 is the absence of a number, 0 is neither positive nor negative. So if you take the negative of 0, that's just 0. And in fact, 0 is neither positive nor negative. It's in between the two. It's a very special number. The opposite of negative 5.1 is the negative of negative 5.1, which becomes positive 5.1. Right? Negative 5.1 is around here. The opposite of that would be 5.1, the positive of it. Okay, and then negative 3/7 is just going to be, the opposite of 3/7 is just going to be negative 3/7. So for all of these, we're looking at two things. We're looking at the sign of the number, positive or negative, or if in case of 0, neither, and the amount the number is. So we had 9, 34, 5.1, and 3/7. The sign is one part, the amount is the other part. Well, finding the absolute value, because we're talking about these kinds of distance here, right? The yellow and the orange, those are distances from 0. The absolute value is kind of it's a good topic to introduce at this point, because absolute value asks, what is the distance of something? It has a very rich meanings in higher levels of mathematics, but for this kind of basic of an understanding of what it is, it's really just saying, what is the distance the number is from 0? So for instance, 6, right? If I drew it on a number line, 1, 2, 3, 4, 5, 6. We're trying to figure out what is the absolute value of 6. We just count 1, 2, 3, 4, 5. It is 6 units away from 0. So the absolute value of 6 is 6. The absolute value of negative 5, 1, 2, 3, 4, negative 5. The absolute value of negative 5 is 1, 2, 3, 4, 5 units away from 0. So it's 5. Of course, the absolute value of 0 is 0 units away from 0. And so now you kind of see what we're talking about here. The absolute value, no matter what's on the inside of it, be it positive or negative, will always end up giving you a positive answer when there's just a number on the inside, because all we're asking is how far away from 0 is the number, which always has to be a positive. Distance is always a positive or 0 number. Now, this next one is negative of the absolute value of 2. So first off, we figure out what is the absolute value of 2. 1, 2. So the absolute value of 2 is 2. So the absolute value, this portion here, is 2. We have the negative of 2, and negative of 2 is just negative 2. That's like saying the opposite of positive 2 is negative 2. The last one, the absolute value of negative 8, that's going to be equal to 8. So this portion here is just 8. Now we have the opposite of 8. The opposite of 8 is negative 8. And that's our answer there. All right, now that we've talked a little bit about absolute value, we can go on to more complicated structures. So we're writing true or false for each statement. Is the absolute value of negative 8 greater than 0? In other words, is the distance from 0 of negative 8 bigger than 0 or not? So the absolute value of negative 8, you can, of course, look at a number line, negative 8's over here, and then count, it's just going to give you 8. And so we have, this thing becomes 8 greater than 0. Is 8 greater than 0? Yes, it is. So we have a true statement. The absolute value of the absolute value of negative 2 equals 2. We ask, how far away is negative 2 from 0? It is 2 units from 0, and 2 does equal 2, so that is true. The absolute value of negative 6, how far away from 0 is negative 6? It's 6 units away from 0. How far away from 0 is -5? It is 5 units away from 0. Is 6 less than 5? No, it is not. So we have a false statement. Okay, we have 3 less than the opposite of -4. The opposite of -4 is +4, and 3 is less than 4, so we have a true statement. Here we have the opposite of the distance of -9 and the opposite of the distance of -15. So the distance of -9 is 9, and the opposite of the distance of -15 is 15. Is -9 greater than -15? Yes, it is. -9 is further to the, if we have 0, we got 1, 2, 3, 4, 5, 6, 7, 8, -9, 10, 11, 12, 13, 14, -15. 9 is right here. It's further to the right than -15, so this is true. -9 is greater than -15. With the understanding of negatives, now let's look at adding and subtracting them. We can do this all on a number line to get understanding, but it really only works for small numbers. Before doing this, we need to understand how to handle two signs that are next to each other, that are like right next to each other. For instance, plus and -2. The parentheses are just there to designate that -2 is its own quantity. So the plus and the negative are actually right next to each other when you do the mathematics. Okay, if you have two pluses, like right next to each other like that, or just plus and plus, this all equals a plus. If you have two negatives, or like this, see, there's one there. Here, like this, we have two negatives here right next to each other. Then they become a plus. If we have a plus and a minus, like we do right in our first problem, plus and a minus, this is going to equal a minus, and then the opposite form is also going to be a minus. If you notice here, two of the same signs becomes a plus, and one of each sign becomes a minus. Two negatives will always cancel, and depending on how many, sometimes you can have a string of negatives, and as long as you have pairs will always cancel. Now this rule is interesting because it's not only effective for addition and subtraction, it's also the rule we're going to use for multiplication and division. That's going to be coming in the next videos. But we're going to use this property to simplify each statement to where there's only one sign in between the numbers. So here we have 8 plus a -2. So we have 8 plus a negative. Let's see, plus a negative. That becomes a minus. We have 8 minus 2. And this is a little bit simpler. This is just subtraction like you normally would. 8 minus 2 is 6. Okay, now here we have -7 plus 10. None of these rules here apply to this problem because the signs are not right next to each other. In multiplication and division, the signs don't have to be. They're going to apply more there. But for this problem, and for addition and subtraction, which you know is the case because we have only a plus in between them, or only a minus in between them, like we did in the previous problem, then we cannot use these rules here. What we have here is -7 plus 10. If you don't know how to do this, you can of course do this on your calculator, but a number line can help out your understanding. So first off, let's put 0 to have a reference point. 1, 2, 3, 4, 5, 6, -7 is right there. That's the first number, so that's where we're going to start. We're going to put a little stick man right there. And we face towards the right. The right is the positive direction, the left is the negative direction. So we're going to go this way. And how far are we going to go? We're going to go 10 units that direction. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, which means negative 7 plus 10 equals 3. The 10, you can also think of it this way, the 10 is a bigger positive number than the 7 is negative. So we're going to have a positive number, and because they're different signs, you can subtract the numbers. 10 minus 7 is 3. It's going to be positive 3. Okay. Plus and minus, that becomes 5 minus 9. This we can, of course, use a number line. 0, 1, 2, 3, 4, 5. We're standing right on this point here. We are facing the negative direction because, right, as you go more positive, you get, as you go to the right, you get more and more positive. As you go to the left, you get more and more negative. So we're facing the negative direction, so we're going to go face left, and we're going to go forward 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, negative 2, negative 3, negative 4. So 5 minus 9 is negative 4. Okay. Here we have negative 6 plus a minus 3. Plus minus becomes negative 6 minus 3. And you can use the number line. Start at negative 6. We start, here, let me use different colors here. We start at negative 6. We're going to face left. That's the negative side. And we're going to move 3 units. So we go from negative 6 to negative 7, negative 8, negative 9. This is going to be negative 9. All right, this one becomes 12 minus 12. 12 minus 12 is 0. Okay, if we have a longer string of numbers like this, just take them one at a time, pairs at a time, I should say. Negative 34 plus 17. In this case, the numbers are way too big to use a number line. So let's kind of introduce you to another idea of thinking about this. And that is that if we have 2 numbers that are different signs, in this case, one's negative and one's positive, we're always going to subtract them. 34 minus 17 is 17. Now the question becomes, what sign is 17? Whichever one is the greater absolute value, 34 is a greater absolute value than 17, which means we're going to take the 34 sign. It's going to end up being negative 17. You can see this by just changing the negative 34 and putting the plus there on 17. That gives us, this right here is the exact same thing as what's written here. Negative 34 plus 17, that's what I had written there, equals negative 17. Okay, so we have negative 17 plus a minus 88. Plus a minus is a minus 88. Plus 5. So now we do negative 17 minus 88. In this case, they're both negative. If they're both negative, that means we add the numbers together. If they're the same sign, you add them. If they're different signs, you're going to subtract them. So the same signs, 17 plus 88, it's going to be 5, 1, 105. And then if we go minus, minus, we get a minus 105. This equals negative 105 plus 5. Here we have a negative and a positive. So we're going to subtract the numbers. 105 minus 5 is 100. The 105 is negative. 5 is positive. That means this is negative. So we get negative 100. It's all about understanding how do positive and negatives interact with each other, and then trying it out. You can always use the number line, but when you have big numbers like we did here, it becomes a little bit harder to work with. You can do it, but it just becomes harder to work with. That's where having the same signs, you add them up, different signs, you subtract them, and then take whatever sign is bigger. Okay, in this case, we can use a calculator for this because it's a decimal number. But what you can think of is this instead as 1 minus 0.4. Addition and subtraction has the commutative property. As long as you keep the sign on the number, then you can do that. And the way you know how to do that is to make sure there's only one sign that you're working with, right? If I had 1 minus a positive 34, this is not the same thing as positive 34 minus 1. That's because there's two signs here. We need to first write 1 minus 34. And now you see that the 1 is positive, right? If there's nothing written in front, then there's a plus there. And the 34 is negative, which means we can now flip these around and say negative 34 plus 1. These are the same thing. And you can see how these are not the same thing. The 34 becomes positive all of a sudden, the 1 becomes negative. No, that's not correct. So we can use the commutative property in addition and subtraction if it helps us out. 1 minus 0.4, this is 0.6. Taking away 4, you can kind of think of this as like 10. 10 minus 4 is 6. So, but we leave the same decimal points where they're at. Okay, 3 minus 19. Hopefully you're gaining a little bit of understanding here. We have one of each. We could definitely do this on the number line. This isn't that big of numbers here. But let's do it in the other way I taught you. We have one of each sign. 3 is positive, 19 is negative. So we're going to subtract the two numbers. 19 minus 3 is 16. 19 is a bigger number, bigger absolute value, and it's negative, which means we have negative 16. 19 minus 3 is 16. 19 is a bigger number than 3 is, so we're going to take the sign of 19, which is negative. That only works if we have one sign in between. So here we have two negatives. Let's change it to a positive. And this is normal addition. 7 plus 4 is 11. All right, negative 5 minus 5. These are both negative numbers, which means we have two of the same signs, so we're going to add them. 5 plus 5 is 10, but it's not going to equal 10, right? It's going to equal negative 10. They're both negative. We add them together to make a more negative number. The same thing with number 11 here. Negative 23 minus 6 is going to be negative 29. Okay? We have negative 2 minus 4 minus 9 plus 8. Negative 2 minus 4, those are both negative. So we're going to add them up. Negative 2 minus 4 is negative 6. We have negative 6 minus 9 plus 8. Negative 6 and negative 9, both negatives again. Add them up, we get negative 15 plus 8. And negative 15 plus 8, those are one's negative, one's positive, so subtract the numbers. 15 minus 8 is 7. And the 15 is more negative than the 8 is positive. The 15 is a bigger number, so we have negative 7. All right, 1 minus a negative 1 becomes 1 plus 1, plus 6. Plus minus 6 becomes a minus 6, and a minus 2. 1 plus 1 is 2, plus 6 is 8. 8 minus 6 minus 2. 8 minus 6 is 2, and 2 minus 2 is 0. Okay, last problem here. I'm just going to change this all into being one sign in between. Plus and a minus becomes a minus. 2 minuses become a plus. Plus 0.7 minus 9.9. Now we have 6.5 minus 8.3. Honestly, this is probably a good a good number to use a calculator. You could do 65 minus 83 plus 16 plus 7 minus 99, but I think it's going to be more prone to errors, and you can get it all done really quick with a calculator. And I get 10.4. Jiffy Print Shop has a daily work quota, and during the first 2 weeks of last month, the daily comparisons are shown. We have plus 30, minus 27, minus 15, so on and so forth. The plus means the shop exceeded the quota, and the minus means it was below. How far below or above was its quota for the whole 2 week total? So the way we do this is all we have to do is add up all the numbers together. In other words, we just take 30 minus 27 minus 15 plus 8 minus 6 plus 12 plus minus 22 plus 56 minus 61 plus 47. This is definitely a job for a calculator, so we can do it all in one go. And I get that it was $22 above quota. That's good for them. All right, Pedro's checking account contained $489 on June 1st. He then made the following transactions: deposited $150, withdrew $225, and so on and so forth. What's the new balance? Well, if he started with $489 and then he deposited $150, that's a plus $150 into the account. And a withdrawal of $225, and then withdrew $34, deposited another $119, withdrew a $365 transaction, and then deposited $750. So let's add these up. Again, a calculator is the way to go here. He ends with a balance of $884. Okay, we got fit allowances for plumbing. Has negative allowances of negative 2 1/2 and negative 7/16 inch, and two positive, each of 1/2 inch. What is the net fitting allowance? So all we really have to do here is just add up all of them. We have negative 2 1/2 minus 1 7/16, and then we have two positive allowances of 1/2 and 1/2. I'm going to change these into improper fractions. 2 times 2 is 4, plus 1 is 5 over 2. 16 times 1 is 16, plus 7 is 23 over 16, plus 1/2 plus 1/2. Okay. Now let's get these all to be common denominators. So 16 is the least common denominator. I can get that by multiplying by 8 on all of the 2's. 2 times 8 is 16. That gives us negative 40 over 16 minus 23 over 16 plus 8 over 16 plus 8 over 16. Both of these are minuses, so we can add the two numbers up. 40 plus 23 is 63, and it's going to be negative 63 over 16. And then you can actually, just to kind of give you a tip on speeding up your process, addition and subtraction can be done at the same time as long as you're kind of working separately from a previous thing. I can actually add plus 8 over 16 and 8 over 16 to make plus 16 over 16 in one go. If that doesn't make sense to you, just do it, the next step is going to be plus 8 over 16 onto the negative 63 over 16 and plus 8 over 16 again. It's the same problem. It's the same answer that you'll get in the end. Now we have a minus 63 plus 16. We're going to subtract the two numbers. 63 minus 16 is 47. And 63 is a bigger absolute value, so it's going to be negative 47 over 16. This doesn't have, can't be reduced, but we do want to make this into a mixed number. We started with mixed numbers here and here, and so we want to end with the mixed numbers. We also know the units are going to be in inches. So how many times can 16 go into 47? It can go in there twice, I believe. So there's going to be negative 2. 16 times 2 is 32. And 47 minus 32 is going to be 15. We have -2 and 15/16 of an inch. That's the allowance for the pipe configuration. Okay, here we have currents that are flowing into a node. This is electronics. This comes from Kirchhoff's circuit laws, or Kirchhoff's circuit laws, however you say it. And all we have to do really is add up all of the amperages going into the node. And all of these are going into it. So adding them all up gives us, I'm going to start with I1 here, and then work counterclockwise. So we're going to go 15.1 milliamps minus 7.2 milliamps minus 4.5 milliamps minus 3.4 milliamps. And when we do this, we can just by calculator, 15.1 minus 7.2 minus 4.5 minus 3.4. You'll see we get 0. And that's actually Kirchhoff's circuit law. It says that all amperages going into a node and going out of a node must net to 0. All right, Dave's auto shop was $2,465 in the red, so negative $2,465 at the end of April. They owed this much to their creditors. That's what that means. At the end of December, they were only $648 in the red. How much money did they make in profit between April and December to achieve this improvement? So this is still in the red though. So they still owe $648, but they've paid back a lot of it, right? They've paid back from $2,465 to $648. The way we can do this using arithmetic is taking the starting amount and subtracting it from the final amount. You can do this the other way around. You can take the final amount minus the starting amount. It's going to end up changing whether or not your answer is positive or negative, and that really only matters for like doing continued mathematics. Here we know what the final amount means. That's the improvement that they paid. That's how much they paid back. What you're going to see here is that we have plus and minus becomes, or sorry, minus and minus becomes a plus. And that gives us, actually, I need to do this the other way around. It's the final amount minus the initial amount. That's always the strategy you should use, is the final minus the initial. There's going to be multiple problems like this that we're going to see. But you always do final minus initial. Negative 648 minus negative 2465. I'm going to continue doing this way, and I'll show you what the difference is in the final answer here. So negative 2468 plus 648, you know the answer is going to be negative because this number is far greater than this number. So we're going to have a negative number. And using a calculator, gives us 648, negative 1817. Now, doing it the proper way, the way that you should do it, is final minus initial. This still gives us a plus. You get negative 648 plus 2465. And this says the positive version. And that's the big difference. The way you write this out is going to give you a plus or a minus. Now, in some cases, it doesn't matter as long as you know what the final answer should be. It doesn't matter which way you do it. But the best rule of thumb to do is final minus initial. That's what this top way is. Don't do it this bottom way. Get in the habit of doing final minus initial. That's what I should have done in the beginning. What this means is that the improvement they made is that they made a payment of $1,817 to the creditors, and now they owe less money. We have a temperature plunge, which is the fastest chill, which is quite a plunge. 44 degrees Fahrenheit to negative 54 degrees Fahrenheit. By how many degrees did the temperature fall? It fell the final minus the initial. It started at 44 and then it fell to negative 54. So doing this, they're both negative, so we're going to add the numbers up. Adding them gives us 98. It's going to be negative since they're both negative. So the temperature fell 98 degrees Fahrenheit. The negative means it fell, and this is by how much it fell. All right, we have a machinist doing a calculation. He needs to do this calculation here, figure out whatever he needs to do for that. 5 minus parentheses here mean we have to do this first, right? Order of operations still applies. So doing the inside first, we have a positive minus a negative. That's a normal subtraction that you're used to. 3.750 minus 0.500 is 3.250 minus 2.375. Now these parentheses actually don't mean anything. If there's just a number inside, you can drop the parentheses. And we can do this how we normally would. This is really a job for a calculator. 5 minus 3.250 minus 2.375. That gives us negative 0.625. All right, and here's our last problem. Suppose a utility charges solar power customers $3.50 per month for each kilowatt of installed capacity, but they compensate the customer 9 cents for every kilowatt hour of electricity that's exported back onto the grid. So they charge it for the capacity, but they actually pay money back to the customer depending on how much they give back. So we have two situations here. For the first one, the homeowner has a 3.5 kilowatt solar system. That's how much they're going to be charged per month. 3.5 kilowatt, and that says 350 for each kilowatt of installed capacity. It's a 3.5 kilowatt system, so we have 350 times 3.5. This is how much is being charged to the customer. So that's a good way of thinking about that, is saying this is going to be the negative. That's how much you're going to owe the utility company. And the homeowner exports, so this is how much they gain from the utility company. They export 108 kilowatt hours. Well, that's going to be the 9 cents per kilowatt hour of electricity. So we have 9 cents times the 108 kilowatt hours that are given back to the grid. So we use order of operations. Multiplication and division first. We can actually do both of these at the same time. That's because they're separated from each other. And what we have here is going to be negative 3.5 times negative 3.5 is negative 12.25. This is a little kind of preview for next time. Negative times a positive is negative. And then plus 0.09 times 108, 9.72. Now we have negative 12.25 plus 12.25 plus 9.72. That means the customer is charged $2.53. Okay. Part B, same process. Now I have a 4.6 kilowatt hour solar system, or just kilowatt solar system, plus the 0.09, and they export now 258 kilowatt hours back to the grid. So let's do the multiplication. 3.5 times 4.6. It's going to again be negative 16.1. 0.09 times 258. This gives us 23.22. This one here, you see that the positive is much bigger than the negative, which we know is going to be a positive answer. and that gives us 7.12. So they actually make money back because they exported more money to the grid than the capacity charged them for.